Hello and welcome everyone. In today's video, we'll be building a real-world example of large language model-based interaction in an AI application that processes natural language and invokes certain external APIs, in our case a weather API, does some processing, uses some logic, and then sends the final response back to the user. And an application like this involves several concepts, which is what we'll learn today. So even if you are a beginner or you are an advanced user, I'm pretty sure you will find something out of this video. So stay with me till the end of the video and watch all the aspects that I'll be describing today. So in this example that I'm showing, this is what we'll be building today. And in this example, you see that we are building a request initially. And the request is what the user wants to know. Is it hotter in New Delhi or in Minneapolis? A follow-up question along in the same line is, how hot is it? And I want to plan a visit to a cooler place, right? So it's a complex question. It's in a natural language. And we are trying to get a response back from LLM. Now, LLM will not know the answer to this question. So what we want is for the large language model to go out, reach out to a weather API, get the answer, and then compare the responses back from New Delhi and Minneapolis, evaluate it, and then give us an answer back based on the weather information it received from the two cities. Right, so how do we do this? How do we create a request object for a complex question like this? And how does the flow work, right? So you see how we had the first request, we sent that request to a particular endpoint, and then we got a response back, and the response back was tool calls, and we'll go in details about all of these things. But then once we received the tool call response back, the application was able to reach out to an actual weather API endpoint, and it collected the weather details from two different endpoints. So over here you see it collected the weather details for New Delhi and then for Minneapolis, and then it passed that information back to the large language model, and then the large language model was able to process it, and it said that I used tool calls to determine the current temperatures in New Delhi and in Minneapolis, and then it found out that New Delhi is hotter, and in this case Minneapolis will be better destination to travel if you prefer cooler temperatures. How awesome is that? So how do we build an application like this? In order for us to understand this, there are several multiple key concepts that we have to understand, and I will go over all of this one by one in this video. So number one, let's go and let's take a look at OpenAI developer platform. So in this video, I'll be using Ollama. I'll be using a free open source locally hosted Ollama. However, Ollama has come up with an OpenAI compatibility layer, right? So they have this V1 chat completions endpoint that is one-to-one compatible with OpenAI. So any code that I'm showing to you today can be done both in OpenAI and in Ollama server. So I'll be using Ollama, but it is exactly one-to-one correlated to OpenAI as well. So everyone is following OpenAI standard. This has de facto become the standard for using the APIs now. So I highly encourage all of you to go over here to the developer portal and just to take a look at some documentation. And I will go over the most important documentation aspects and concepts over here, and then we can extend this to our application that we are going to build. So the very important concept are there are two main endpoints that you'll be dealing with. One is a chat completions endpoint, and another is a legacy. I think it's down below somewhere over here in the legacy completions endpoint. Oh, there it is, completions endpoint. So there are two endpoints that they have, a chat completions and completions. And what's the difference between these two endpoints? So let's take a look over here. So when we send a request to a large language model, right? Let it be either Ollama or it could be OpenAI. right? So you can specify which server you are sending your request to. But either way, you are in the end, you are describing which large language model you are attempting to send your request to. So in our case, if we are having Llama 3.1, then we are sending a request to Llama 3.1 and we are trying to get a response back. So there are now two endpoints that we have. So first endpoint is in general called generate, or you can call it completions endpoint. And the second one is called chat completions, right? So there are two endpoints we're talking about: generate endpoint, which is also known as completions endpoint. And then there is chat completions endpoint, right? So there is a difference. So that's why, so that we do not get confused, I'm writing it as generate, because in Ollama it is referred to as generate, and in both Ollama and OpenAI, chat completions is referred as chat completions, right? So v1/chat completions, if you want to write that, we can do this over here. So v1/chat completions. All right. So what is the difference between these two endpoints? So in order for us to understand the difference, let's open Ollama's GitHub page, and they have a very nice, example over here that will make sense. So in generate endpoint, what we do is we just send a request. We just send one single request, and we expect the large language model to finish that response, that request, and send it back as a response, right? What do we mean by that? So if we take this example, if we take the generate example that we have over here, so let me take this example. I'll copy this and let me clear this out, and I'll paste this over here. And the only difference is that my model is hosted on the server called AI, right? So it's in my basement. It resolves to 192.168.1.10, and it is hosted over here. So if you send this, so you see what we are doing is we are just choosing the model Llama 3.1, and we are sending a prompt over here. And if you see, it is just, generating a bunch of different things, and I'll explain it to you what's happening over here. So let me go on the very top. All right. So we ran a curl statement, and we said that, hey, can we do a get for our AI 11434 API generate? So this is the endpoint, and this is the request that we are sending over here. We are sending that for model Llama 3.1, the prompt is, why is the sky blue? And the model is now trying to complete the sentence. It's trying to generate the next words that will come after this sentence, right? So the model thinks the next words are, the sky appears blue to our eyes because of a phenomena called Rayleigh scattering, right? So it is generating tokens. Every single one of these is actually a token response back. So it is generating tokens, and you are seeing that all these tokens that it has generated, right? So 19 is one token, and th is the second token. So a token may not be a full word. A token may or may not be a full word. For example, if you see scatters, right? So scatters has been broken down into two different things. So a token will always not be a full single word. It's very important that we understand that. And you can also see over here, Earth, right? So there is an apostrophe and S, there is a space added over here. So a token is not one single word. I'm just emphasizing on this because this becomes confusing to a lot of developers, because we tend to think that one full word is a token, which is not the case. A token can be multiple words together. It can be one word broken down into smaller words too. So model is just generating tokens, and it is sending the response back, right? So it generated the tokens, and in the chat completions endpoint, it just completed this particular sentence, and it kept on writing after it. And once it felt that there was an end of token that was received, it finished its response, right? So this is what is happening from the generate endpoint. But many times this is not what we are looking for. When we are doing a request and response against the model, we want to have the model aware of who was talking, right? So if user as me was sending requests to the model, right? So let me go back to this diagram over here. So if user was sending the request to the model and model was responding back, we wanted to have that determination and distinction that, hey, the first request that is being sent from the user is user, and the request that is being sent from the model back is, let's say, assistant, right? So then the concept of user and assistant came into picture. And let me pull this diagram over here now. So now what we are saying is that, so generate endpoint I already showed to you, it has been deprecated. I don't use it anymore, and it may have its use cases and purposes, but let's focus on v1/chat completions endpoint, right? So this is what we'll be focusing today. So what is chat completions endpoint? So in chat completions endpoint, we say that, hey, this is the request that user has sent. So this is the user request, and this is the response that model is sending back, right? So there is an assistant response back, and then you can continue your request by sending user assistant like a normal chat operation that is going on. So when you go to chat GPT, this is what is actually happening in the background. There is a user assistant kind of request response that is happening, but we send the whole user assistant request response for every single request. What does that mean? Let me show you with an example. So this is an example. So let me show you this test.py. So when we take a request, right? So I'll show you what this code means in a second. But when we take in a request, we have to annotate that request that, hey, this is the user request. And when we get the response back, we have to get the response back as an assistant response back. And then when we are sending the next user request, we are building the request in such a way that both previous user and assistant requests are part of it. And then the third user question is being sent along with it. It will make sense when I show you the example. So bear with me when I'm talking about this. It may not make sense now, but when I show you the example, it will make sense. So let's take a look at this example. So in this example, we are determining or defining the payload. In the payload, you see that I have said, I want to use a model Llama 3.1 70 billion parameter model, right? And what I'm saying is that for my messages as role user content, hey, right? So what I'm saying is that the very first request, so let me show you what's going on over here. So I'm going to move all these out. The very first request that I'm building is just the role user, and the content of that is hey, right? So that's it. I'm just going to send a hey to the large language model and see what happens. And how do I do that? I just get to the chat completions endpoint, right? So the same AI server that I have, it resolves to AI or ai.mtcl.lan. They both resolve to the same domain, localhost, local.192.168.1.10 in my DNS. And this v1 chat completions endpoint is where we want to send the request to. So in your case, you can just have localhost over here, and that should be sufficient. We don't need an OpenAI API key for Ollama because Ollama is compatible with our OpenAI endpoint. I'm just passing this API key. You don't need it. I don't think you even need to pass this one. But if you're using an OpenAI endpoint, then you can specify that, and then you will need to pass this. All right. So we are just going to send this particular request with this payload to this endpoint, and the headers are just like this. If you are using an OpenAI, then you can use the OpenAI endpoint, and then you'll have to pass your API key over there. In this case, we don't need it, but still, it doesn't hurt to pass it right now. What we are doing is we are saying response. We are posting this request to this chat completions endpoint. We are posting this request, this payload to the chat completions endpoint, and we are printing the data that comes out of it, right? So let's see. So let me run this Python test.py. So this is test.py. Let me run this and let's see what's the response back. So I think there's the model loads on my server over here, which is what will take a little bit of time. So this is a 70 billion parameter model, which is loading right now. So it'll loop through all the 3090s one by one, break down about 10 gigabytes on each 3090, and then it will return the response back. So the very first load, of course, it takes some time, but once the model has been loaded, it won't take time. So just waiting for the model to get loaded, and the model has been loaded now, and it is processing the response now. All right, so you can see the chat completions endpoint sent me the response back. The response that I got back has a bunch of data in it, and the most important answer is this, the message attribute, which is in the choices message attribute, which says role assistant, right? So this is pretty cool. You have this role assistant now, which is what you want from the conversation back, right? So you have sent role user with content hey, and you have gotten back role assistant with content whatever it has sent you back, right? So you started with just the user, and you have received this assistant response back. Right now, what we have to do is we have to build this user response and then send it back to LLM. Right? So if you are continuing the conversation, you will have to take all these three aspects of it and then send the response back. So let's do that. What we'll do is we will take this particular role assistant. I'll copy this and I'll paste it over here, right? So I'm going to put a comma, I'm going to hit enter, and I'm going to paste this. So you see what happened is I now have a role assistant content. It's nice to meet you. Is there something I can help you with? Or would you like to chat, right? So you already have the answer from the assistant back. And now you want to ask a follow-up question. So how do you ask a follow-up question? You can just send another role user back over here, and you can say nothing much, right? Let's just send this back to the LLM and see what happens. So now we are in a conversational mode. We are user, assistant, user, and then let's see the role of assistant back, right? So we got an answer back from the assistant over here, and it ends would you rather right here, right? So it ends right here. So this is the point I was trying to make, that you are the one from the application point of view where you will receive the responses back, and you will keep on attaching it to your payload, and you will build your request response objects, right? So you start with a simple first initial question. The model then responds back to you with an assistant role and its content. You bring it back into your payload, the assistant role, and then you add your own user role and you ask a follow-up question. Once you ask this follow-up question by sending the whole message object, so the key is that you have to send the whole object back to the large language model. And once you do that, then you will be able to continue your conversation back, right? So now you can continue the conversation back. You now got the next assistant a response back over here, and you will have another role, and you will say, I do not want to play, right? Whatever we send over here, and let's send it back to the large language model and see what it talks back. So now it will generate a response back, and it says, so it says that, yep, sometimes people just need companionship or whatnot. So it is being nice. It is sending us a response back, and we can keep continuing this conversation if we want to. So if you see, slowly and slowly, by adding every single message to the request, we are growing the request over here, right? So we are adding the request, adding the previous messages to the next request, and every single subsequent request is becoming bigger and bigger, right? This is what is called as the context length. So we started with a very small context length, right? So the context length is the number of tokens that you are giving to the large language model for it to generate the response back to you, right? So originally you had a very small context length, right? You had a very small request object that you had. Once you got the first response back, then you built these two and then your own question, and then you sent it back to the large language model. So your context length grew, and then your context length grew even more, and then even more and even more. And this is slowly and slowly going to be more and more expensive for the large language model to process, right? So the input context length is what normally these large language models talk about, that this is their context length that they support. So many times you would see or hear that the context length for these new Google models are 1 million tokens, right? Or the context length for Llama 3 is 8K. And this is what they're talking about. This is the context length that they're talking about. All right. Llama 3.1, I believe, is 128K. So we have enough 128,000, well, 1024 multiplication and all that, but at a high level, 128,000 tokens context length is sufficient for a lot of operations that we would do. It's a lot of tokens that can be sent, as you can already see, and I already explained to you what a token actually means in this other example, right? So a token is not the full word, but a token is actually, this is what they're talking about in terms of the context length. So tokens context length. All right, so now that you understand what the chat completions endpoint is, how do we utilize chat completions endpoint by passing role user, role assistant, role user and assistant, right? We keep on making alternate user and assistant roles. Are there any more roles that exist? And the answer is yes. So there are 2 more roles that are quite important when we are building a request object for our large language models, right? So what are those 2 roles? Let's get back over here. So one important role that we have is system. So let me pull all these down a little bit. So system role, what is a system role? So system role is something where we give a character to the large language model. We tell the large language model that you need to use this role, and this role is used to provide a high level instructions or context that guides how the assistant should behave throughout the conversation. Right? So for example, you might want to use the system role to instruct the model to maintain a formal tone, or you wanna have it a funnier tone or Shakespearean tone, right? Or to avoid specific topics. This is set at the beginning of the interaction, and it shapes the overall behavior of the assistant. So how do we set a system role to our large language models, right? So let's take a look over there. So in order for us to set a system context, let me delete all these interactions that I have, everything. Let me get rid of this. Let's get back to the original. Okay, so this is our original message where we had role user. And if we just send this to the large language model, let me see if the model is already loaded. And the model is loaded, and let me send this back again, and you will see it just sends a very simple how is it going, right? So the role assistant is a very simple how is it going, is this something I can help you with, right? So all right, I mean, it is sending a simple using a system context, whatever is by default built in. But if we want to change that, if we want to use a context, our own defined context, we can do that. And how do we do it? We can make it as system, and we can put the context as you are a funny AI assistant that tries to mimic C3PO robot. I don't know, I just made something up over here, and let's see. So if we give this as a system context, so let's see what the response would be now. So the response before giving it the system context was, how is it going? Is there something I can help you with and whatnot, right? And now let's change the system context over here and let's send the request back and see what happens. So now, okay, all right. So you see it is having a funnier response back. I flail my mechanical arms. Oh dear, a human is addressing me. Greetings, master, and all that. You see how the whole conversation context changed, and it has now started talking like a C3PO robot. And if we change this, that you are a very serious AI assistant who is very reserved, right? Only respond in 1 or 2 words. So I'm gonna change this context over here, and then let's send the same request back and see what happens. So now it just said hello back. Wow. So it was very reserved, right? So I said hey and it said hello, right? So very, very reserved, and it only responded back in 1 or 2 words. It chose to respond back in 1 word. So this is what a system context means. System context is very helpful in defining what application you're building and giving the model, some kind of view. Like you are treating the model as a very intelligent being, right? That is the whole concept, that you're saying that, hey, I don't want to do the work, but I want this AI to do some work for me, to automate some tasks for me. But how does an AI know what you want it to do, right? So you give it a system context. You tell that, hey, you are an AI that specializes in doing market research, right? Or you are an AI that specializes in using some weather tools and gathering that information from internet. Or you are a smart assistant that specializes in translating languages. So now the whole thought process of the large language model just models around that. It thinks in that way. It actually models its character in terms of the system prompt that you are building and you are providing to the language model at the start, right? So if I go back over here, there's only one single system prompt. So after one system prompt, you keep on sending your user request. Assistant will answer based on the system prompt. It will answer that. You will send the request again. It will answer that, and the flow will continue to go. All right. So we know now what a system prompt is. We know what the user role is, right? So system role, prompt, same difference. So system role, user role, assistant role, right? And then there is one more role which is called as a tool role, right? What is a tool role? So a tool role is when you are calling a function and when you are requesting the large language model to perform an operation that it cannot perform by doing just a text generation. Right? So if a model cannot just generate a text and give you the answer, if you ask the current weather information, it just cannot come up with the current weather information, right? It just does not know it. It has to get that information from an external function. So this role represents the invocation of an external function or an external API that the assistant can call to perform a specific task, right? So for example, if you want to retrieve a data from an API, or if you want to execute a command, then this tool role is what is depicted by that, right? And we'll see what it means in a second. So a tool role is where, let's say the user has originally asked a question that what is the weather, right? So let me change this color over here to something else, maybe, yeah. Okay, so if the user has asked what is the weather, And the response that assistant gave back is, I do not know the answer to what the weather is. However, if you run this tool, right, if you run the get weather tool, then you can get the answer back. So the assistant is still saying this, that, hey, you need to run this get weather tool to get the answer back. The key over here is assistant does not run this tool. Assistant just tells you to run the get weather tool, right? So what you'll do is now you will run the get weather tool. So by you, as in the Python application that you are writing, will now run the get weather tool. It will get the response back, and then you will attach a tool message over here with the response back. And it will all make sense when I show you the example, but I just want you to see the flow over here. So you are initially passing the question, what is the weather? Assistant is responding back with, oops, well, I do not know what the answer is. But if you run the get weather tool, then you can get the answer. So now that you have gotten a response from the assistant that you need to run a tool, you will run that tool. So the Python script will run this tool. And once it runs the tool, it gets the data back. And the data that it gets back, it puts it in this tool role. And once it sends the data back into the tool role, it sends the request back to the large language model. And then you get the answer back from the assistant, right? So whenever there is a tool call, this is critical to know. A tool call involves first assistant call that says which tool needs to run. You as a user will run that tool. Once you run that tool, you get the answer back. You attach that answer back to the whole sequence of conversation that is happening into a tool call response back. And then you send that whole request back to the large language model. And large language model now understands that, hey, in the previous request, I had asked the user to run this tool. Looks like user has now run this tool and he has attached the tool response back to me. So now I'm capable of answering the question. And this is how it answers this question back to the user. So this is very critical because tool has a tool ID. So anytime when an assistant says that, hey, run this tool, it also tells it that, hey, yes, go ahead, run this tool. And there is the tool ID. So whenever you return me the tool response back, attach that ID also to it. So we know that this particular tool response is based on the assistant's request, right? So assistant requested you to run a tool, get the answer, and attach it back to me. And you did run a tool, you did attach it back, and you also associated the tool ID that the assistant generated, right? So that's how it makes that correlation over here. And we will take a look at this in the code pretty soon, but I wanted to explain these 4 roles that exist. And this is very important for you to understand the application that we are going to build, right? So let me summarize before I move forward. The very first role that we have is a system role. System role is used to provide a high-level instruction or context that guides how the assistant should behave throughout the conversation. Second is the user role. The user role represents the inputs from the human user in the conversation, and it includes the queries, requests, or any statements made by you as a user. This is the main way for you to interact with the model, guiding the flow of the conversation, right? This is the human in the loop interaction that we are talking about. Then we have assistant role. Assistant role is assumed by the AI model itself when it is responding back to the user's input. So this assistant role encompasses the model's replies. It is generated based on the user's queries and previous interactions and instructions that are provided in the system role. So essentially, it is the voice of the AI in the conversation, right? So it's the AI returning back any kind of response to you. It is the voice of the AI in the conversation. Now, the last is the tool. Tool is when a function calling is involved, then the tool role becomes relevant. This role represents the invocation of external functions or APIs that the assistant can call to perform specific tasks. The key over here is that large language model does not call the tool. The tool is called by your program, your Python program, the Python script or the JavaScript or any kind of framework that you are using will be responsible to call the tool. The large language model does not have the capability to call the tool. Okay, and once you call the tool, you associate the response from the tool in the tool message, which is what it represents, the tool role represents. Okay, all right. Now that we know about all these concepts, let's go and let's take a look at what actually is tool calling, because tool calling is the most important concept that many people do not understand, and they make mistakes in the way they are implementing it. Many times we just call a tool and then we think, yep, we are done. I mean, we got the response to the weather, right? So we are done. For example, if the user asked what's the weather in Woodbury, Minnesota, assistant gave a tool call and the tool call response you got as 60 degrees, and that is it, right? You got the answer back. That is it. You never created a tool role and you never associated the tool role back to the chat, and you never got the final answer from assistant back, right? So completing this whole flow is very important, which is what I want to show you step by step in four different examples that I have over here. So these 4 examples will now show you step by step and what mistakes people can do and how to avoid them and how to perfectly execute tool calls in your application. All right, so let's take a look at very basic example, and all these are directly translatable, if that's a word, to OpenAI because Ollama supports the OpenAI compatible tool calling from here on. It's one of the newer features that Ollama has. So if you go over here, I think if you go to the blog, you will see the tool support came on July 25th. Right, so this is huge. This tool support, it is OpenAI compatible tool support, and this is what I wanted to go over. It clearly says that it is OpenAI compatible, and it is pretty cool what it can do. Now, there are some models listed over here that support tools. I have found that Llama 3.1 has exceptional tool calling capabilities. Right? So if you're using Llama 3.1 and if you're using the 8 billion parameter version of Llama 3.1, and if you downloaded it on day 1, right? So then you do have to just delete that model and re-download it. Yes, they first published on Ollama's model over here. They published an incorrect token version of the model, which will not work with tool calling if you want to try that. So that problem was only with the 8 billion parameter 4-bit quantized model. So if you did download it, delete that, re-download it. If you know how to do that, then you can just Google around how to remove and do an Ollama pull again for the same model, right? To update the model. But that's very important. You do need to get the latest Llama 3.1. Llama 3.1 has shown exceptional function calling capabilities. I cannot emphasize. So Llama 3.1 70 billion parameter model, in my experimentation, has been 98% successful in calling functions. And what does that mean? And I'll quickly show you that. So it is so successful that it will be very hard for me to show you the negative scenario because it may not even break during the demo. But if it does break, I'll be very happy so that I'll be able to show you how the function calling capabilities are breaking because Llama 3.1 is so good that it never breaks for me. All right. All that being said, let's go to this example. So in this example, what we are doing is we are asking the large language model about weather conditions, right? So I'll show you the payload over here, and then I'll talk about the function calling capabilities of it. So this is the payload. We are saying that, hey, we want to use model Llama 3.1 70 billion parameter model, right? we are saying that in messages, there are system role and user role. So remember, system role is the role that is used to provide a high level instructions or the context that guides the whole conversation for the assistant. So what we're saying is in system, the context that we are giving is that it is a smart AI assistant and it's master at understanding what the customer wants, and it utilizes available tools if it has any, right? This is a very important statement because we are telling the model that, hey, you do have access to certain tools, utilize those tools, right? So you have seen in the payload these two attributes already. The third attribute in the payload is something that you haven't seen yet, which is the tools attribute. What is the tools attribute? Tools attribute is what tells the model that, hey, you have certain tools available to you, and you may want to use these tools instead of just making up an answer by yourself, right? So if the user is asking, what is the weather in Woodbury, Minnesota? So the model has an option to just go ahead, hallucinate, and generate a response that weather in Woodbury, Minnesota is whatever, right? It can say 22 degrees. But the model is smart enough to know that, hey, I do not know the answer to what the weather could potentially be, right? And the system context says that I have some tools available to me. So shall I see if I do have tools available to me? And in the payload itself, we are giving it certain tools. We are saying that, hey, you do have some tools available to you. So this is where the model will say, okay, all right, I do see that there are certain tools available. The context is saying that you need to use tools if they are available to you. So let me go ahead and see what this tools object is. So now the large language model takes a look at what these tools are. So now let's see, what are these tools actually? So these tools are just a schema. So we define a schema and we give it to the large language model. And we say that, hey, there are certain attributes of this function that I'm going to provide to you. What are those attributes? We are saying that there is type function. This will always be there. And the function itself has the name of get current weather and the description of that this tool does whatever, it gets the weather information. And the parameters that this function would need is a city, which is a string, and the required parameter is city, right? So it needs to always send me this particular required parameter. But how do we know that this is the function definition, right? How do we know that? We know this because we actually do have a function like this somewhere in our application that we will invoke, which is right here. So I have just created a random dummy function, right? The name of the function is get current weather, and this function takes in city as an input, right? So it takes in city as an input, which is a string, and it returns a string as an output, right? So if you see, it takes city as an input and it returns a string as an output. So that is all that this particular function does. It could have had a complex business logic, which is what we will see in our final examples over here. But in this case, it does not, right? So we just have a very simple function that says that, hey, if you pass the name of the city to this particular function, then you will get a response back from it, right? So we define our tool based on the actual Python function that we have. So what is the actual Python function? The actual Python function's name is get current weather, which is what we are using as a name over here, get current weather. Now the second attribute of the Python function is the properties attribute, which is city. The name of this property is city, which is city. The type of this property is string. So we are defining the type is string. And then the required attribute is city. Like we cannot skip this. We need to have this particular attribute in it, right? So we are going to pass this particular tool schema into our payload. Now this is very important, right? That in the payload, we are passing the schema of the function that can return the value of weather. We are not really passing that function over here, right? You can technically just delete this too. You don't even have to have this particular function exist. And you can still process this particular request over here because you are passing the schema. You're passing the schema of the function. You break down this particular function into this schema and you pass that schema as a tool to your model in the payload, right? To your large language model in the payload. And then keep alive -1 just means that just do not exit the model, keep it in there forever. So it doesn't kick out the model from the VRAM of your GPU. So now that we have constructed this payload, we have specified which model we want. We have specified the message with the system and the user. We have specified that, hey, you do have access to some tools too. Now we want to send this request to our Ollama server or to our large language model in general, right? So let's do Python, and this is 00 basic Ollama example. So let me do that. 00 basic Ollama example, and we are going to send this request. So I think the model is being loaded again. Yep, the model will load again. It will take a little bit of time. So just give it a few more seconds. And once the model is loaded, it will respond back. But while the model is being loaded, I'll just quickly talk about it, what's going on over here. We created the payload, model messages tools over here. We have our endpoint URL, chat completions endpoint, API key is not needed over here. We are sending this post request, right? And we are going to print the response back. So the response back was this, right? So this is the response back. And if you see, the key part of this response is in the message role assistant, right? The content was nothing. The content was null, right? In the last example you saw when we ran test.py, you saw the content was the actual role assistant and content whatever. But in this case, the role assistant content nothing, but there is this special tool calls attribute that did not exist before. This is what I mean when I say that the large language model does not actually do a tool call, but it suggests you to do the tool call. So when the user said, what is the weather? Assistant did not respond back with any content. The content was 0, but it said that, hey, there is a tool call over here, right? So this is what I'm talking about. So there is a tool calls attribute in the response, and this tool call attribute says that there is a call ID, which is this one, type function, and the function name is get current weather. The arguments is city, Woodbury, Minnesota, right? So it said that, hey, this is the city attribute that it figured out, and it wants you to run the tool call for get current weather for this particular argument over here, right? And the function finished over here. This is the response back from the function. And once you get the response back, now it is your responsibility. This code over here, this is your responsibility to extract the function, right? So we extracted the function from here, and we said that, hey, if the function name is get current weather, then execute this function, right? So this is where we are executing the function, and we are getting the response back from the function. So this script is what actually executes the function and gets the response back. And when we are printing this data, this Python script is printing this data, right? So this information is not coming from large language model. Large language model just sent us this tool calls response over here. This is it. This is all that the large language model sent us. And the large language model gave us a hint that, hey, if you do a tool call, then you'll be able to get the answer back, which is what we did afterwards. And we executed the tool call and we finished over here, right? So this is the execution that we did stopped over here, right? So we did the tool call and we got the answer back, right? But this does not look right, right? There is no tool role over here, right? We did not make use of the tool role. We should have made use of the tool role. So what happened? So the right way of doing this would have been if we pass the tool role back over here. But before we do that, let's enhance this application and let's go to the second function calling simple example over here. What is this example? So in this example, I've just formatted the code a little bit, and I'm making use of something called weather tool, right? So in this weather tool, I'm making use of this visualcrossing.com, and I found this website on Google, and it is pretty cool because this site gives you 1,000 requests free per day for weather API calls. And if you can see from past few days, I've been using this and I've been experimenting a lot. And yet the maximum I used on this day was 149 calls. I mean, it resets every day. 1,000 a day is huge. I'll never be able to hit 1,000. So very good, API to use. It's free, didn't cost me anything, didn't ask for credit card, just sign up single with username, password, and you get 1,000 free calls a day. And using the example that I have, if you go to your accounts page, you get a key. You can set that API key in your .env file over here, and then you can just proceed from there, right? So if you see, there is in this function calling simple example, I'm utilizing this weather tool. Weather tool is your weather tool.py over here, and in this weather tool.py there is a visual crossing API key, right? So this particular thing you need to have in your .env file. In your .env file, you'll just write visual_crossing_API key equals, and then you will get your key from the account page over here. It is like a 15-20 digit alphanumeric key that you will paste in, and you are all set. Okay, so with this tool, what I'm defining over here is I'm putting a name get weather, right? So get weather is a name of the tool, and what I'm saying is that there is a docstring over here. Docstring is something that defines the function. So what I'm saying is that, hey, this particular function has a name of get weather. It has an input parameter of a string. It takes location as an input parameter of a string, and it outputs a string too, right? So the name of the function, the input parameter, the output parameter, and the docstring, this is what the definition of the function will be, which will be passed in to our large language model in the tools section, right? So we need to provide the definition of the function, which will have the docstring over here, the input parameter, and the output parameter, right? So this is what we are providing. And I have written a nice little tool decorator. This tool decorator, what it does is it extracts some attributes from your function, and it formats it in the structure such that you do not have to write the tool definition every time, right? So for example, if you go back to this basic Olama example, writing such a tool definition is cumbersome. We don't want to do that. We want to have it automatically retrieved from your implementation, right? So this is the function implementation, and this is represented in this tool definition over here. We don't want to be writing all these tool definitions all the time. What we will do is we will just write this definition, this particular implementation of the function, and this helper class over here will extract this tool definition from it, right? So how does it do that? You have to just include this tool decorator.py in your project. So just copy and paste this file into your project, and in your actual function definition, you can just put @custom tool annotation over there, right? So you will say from tool decorator import custom tool, and you will just put @custom tool over here. And what this custom tool does is it extracts the metadata and the definition from the function. So it extracts the name, it extracts these attributes over here, and it extracts what the function actually does by using the docstring. So as long as you have defined a good docstring for it, that is it. Now, whatever your implementation is, it doesn't care because it doesn't need to care, right? You can have just a mock implementation over here. That's it. Your tool definition does not include the implementation, as we saw in this basic Olama example, right? So in this example, you saw that there is no implementation details over here. When you had the definition, it just showed you what the tool does, what's the name of the tool, and the attributes of input, and what is required over here, right? So this is why in your actual function, what is most important is your docstring and you defining your input outputs in a particular way, right? So in the nicer way, just define everything. Just define that your input is a string, right? So location is a string, and having it typed helps for the large language model to identify what is the input type over here. All right, so once you have written your implementation, so in this case, all I'm doing is I'm taking the input location. In this weather API, I'm taking the input location, and I am then just doing a request to the base URL, which is this base URL. So I got all this information from the documentation page of this visual crossing. And this is the base URL. The unit group is US. You can change it to metric if you want. And this is it. You do the post. Oh, you do the get request to this, and you get a response back. And from the response, I'm just extracting some details out, right? So let's actually run this. Let's run this Python file separately, and let's see what the response is, right? So if we run this particular Python file with any location, right? And in this case, I'm just choosing location of Woodbury, Minnesota, and see how the response is coming back over here. So if we do Python weather tool.py, and if we hit enter over here, you will see that it started printing details based on the function response, where it got some data back, and I'm extracting the information out of it. So the current temperature, and then like all these different details I'm extracting out of it from here, and I'm just printing it over here, right? So the return object, which is the function response, looks like this. And you can change it to anything. You can change it to, let's say, New Delhi, UP. Let's do this, and let's run this again, and let's see what happens. So it says that the weather description for New Delhi is partly cloudy throughout the day with storms possible and whatnot. And if I go back over here, so if you see the queries were 10, if I refresh this page, and if it has not expired yet, it will show that a couple more requests were done, right? So 16. So some more requests were done, and it is depicting that too. If I run this again over here, I think it will move to 17, right? So I ran it once more, and if I refresh this page, this query count will change to 17. So you can do a ton of testing with this API, right? And it is 1,000 free a day. I would definitely use this. The response that I get is very accurate. It is interesting to see how they're giving us that much higher limit. But I absolutely love this particular API in retrieving the information back. Okay, so I'm gonna comment all this out. Comment all this out. And I have tested my function, right? So the function works. And also by assigning custom tool to it, now I'll be able to extract the schema of this function too. And how will we use that? I'll show you in our function calling simple example over here. So in this, we have imported weather tool get weather, right? So our weather tool is over here, and our get weather we have imported over here, right? So we have imported that particular function now. Now we have to pass tools, right? We have to pass tools, and in our tools we have to pass the tool definition. So you remember the tool definition looked like all this cumbersome work that we had to do, but by using this tool decorator.py, that helper class that I have created, you do not have to do that anymore. All you have to do is you have to just say getWeather.toolDefinition, and that's it. That's it. You do not have to write the whole tool definition all over again. It will extract the tool definition for you from getWeather function, and it will put it together for you in the correct format. So that huge problem is solved now. All you have to do is create a payload, specify a model, specify the messages. So there is a system message and a user message. In the system message, you have specified that, hey, you are a smart AI assistant and all that, and you have some tools available to you which you can use. So now when you'll be using the tool, or you'll be processing the request, you will be, by you, I mean the large language model will get an idea that I have access to this tool with this tool definition. So let me see if I can run this, right? So let's do this. So what's happening over here is we are going to send a request to the large language model, right? So we have this API URL. We are sending the request to that, a post request to that. And when we get the response back, we're going to print that response. And then we will run the getWeather method if it is part of the response, right? So all we have done, the difference between this example and this example is that we have eliminated the need of defining a function manually, and we are utilizing an actual weather API. Right? So these two improvements we have done in this 01 function calling simple example. So let's run this. All right, so running this, now it is sending, oh, so the model is being loaded again. So let's wait for that for a little bit. The fourth one, and once the model is loaded, it will generate the response back. So just waiting for a couple more minutes over here. Well, seconds, not minutes. So what I've noticed is that when all of these start showing percentages at the same time, that is when the model actually, so like right now, so now the model is running. Okay, so let's see what happened. So the model, we send the request to the model, how hot is it in Minneapolis, right? So a very natural language question over here. So the assistant couldn't respond back to it. So it said content is nothing, but it had access to tools. So it said that, hey, let me see what this tool looks like. So the name of the tool is getWeather. So in the tool definition, it got all that information. That the name of the tool I have an access to is getWeather. So it said that, hey, if you run your getWeather tool and the arguments to that tool are Minneapolis, Minnesota, right? So it structured the request over here for you. And all you have to do now is take the name of the tool and take the arguments and just process it directly, right? So what you can do is you can call the function, you can call this function with the arguments, the way the arguments have been sent back to you, and now you'll be able to get the response back, right? So this is now one of the improvements that we have done, that instead of actually calling the actually defining the getWeather's definition, tool definition completely, you are able to utilize the tool decorator to extract the definition dynamically, right? That's one improvement. And second, that you are using an actual weather API. So you are getting some real information back over here. But we are still in this diagram, we are still like this. There was a system message, user message, assistant, and a assistant said to do a tool call, and we executed the tool call and we got the response back from the tool call, right? We did not put the tool back over here and sent it back to the large language model again. So let's see what the next improvement is that we are doing over here. So now we are doing the function calling LLM with the feedback, right? What does that mean? So in this example, what we are doing is we are doing some of the same things that we have done before. We are importing the weather tool, right? So we are saying that, hey, use the get weather tool that is defined over here in get weather. And the fact that get weather has custom tool annotation on it, we'll be able to just extract the tool definition from there, right? So when we are composing our initial request, everything is exactly the same as before. Up until now, we have our tools. We have extracted the tool definition from there. We created our payload. In our payload, we had several different attributes. We have model, messages, tools, right? So these three main attributes that we have extracted out over here. So model is Llama 3, messages is role system, role user, right? So these are the messages. And then the tools are this tool that you have over here, the weather tool, right? So you constructed your payload. If you see, this kind of payload streamlined way of doing is way more easier to view, and you will see why it is all why is it also good to construct it in this way down the line in the same example. But if you compare this with this example, right, where in the payload itself you are constructing the message, right? So this message, so it also looked clunky. The payload looked clunky, and the way you are now adding or removing the messages from here, if you have to append a new role, it will become more cumbersome. It will become harder to do that. But if you extract that out into its own object, right? So now we have messages extracted out in its own object, and very easily you can append messages to it. So once you have system, user, if you have to append the next role over here, you can do that because your messages is a separate object outside, right? Which is pretty cool. So now you have your payload. Payload has several components. Three main components that you have is model, messages, tools. You have defined all these three outside of this payload object. Most importantly, messages is the one that you'll augment down the line. So let's take this response and how you get the large language model's response by sending a request to this API URL, right? So you have this API endpoint, your chat completions endpoint, and you are sending the request, your payload, to that API URL, and you are getting the response back. Now, once you get the response back, right? This is very important that once you get the response back, now you are constructing a tool messages, right? So this is the tool message error list that you are constructing, and this is what you'll be populating, right? So once you get your tools processed message back, so let me come back over here and explain like this. So once you run this get weather tool and you got that, hey, the weather in Minneapolis is whatever, 55 degrees, then you will be constructing your tool messages. This is what this tool messages array is, right? And then you'll be placing it over here. You'll first construct it, and then you will place it over here in your messages object, right? So let's see how we are doing this. So going back over here, you are constructing an empty array list, and you are going in, and then you are creating a particular response, right? So you're saying that, hey, role, tool, content, weather, tool call ID, right? What is that? So I haven't deleted the previous examples output over here, and this is on purpose so that I can show you a couple things. So what we are doing is we are creating a tool message. Tool message will be one element of the tool messages array, right? So one of these elements is this, which is a tool call. So there is a tool call ID that we have to associate over here. So the tool call ID is this one, right? So ID is call ng8pks7g, whatever this was. So this is the tool call ID. The content is the actual processed weather data, right? So this is the content. This is the content over here. So what we are saying, the content is weather data. The role is tool, right? So once we ran the tool, this is the data that we got back. So we're going to take this tool message and we're going to put it in the tool messages array. Right, so what we're saying is tool messages.append tool message, meaning if there were multiple tool calls, then all those tool calls will be run in this for loop, and they will all be appended into this tool messages array, and all of them together. So everything, will be put together over here, and then it will be put together in the messages object, right? So in other words, this is the messages object over here, and originally we had system and user, then we got assistant, and assistant said that you have to run get weather tool. You ran the get weather tool, you compiled a tool response back in this particular tool messages array, and then you associated it over here in the messages, right, in the chat over here. And let's see how we did that. Okay, so we took this and we associated the tool messages over here, right? And now in the payload, so if you see, what we did is that, hey, if tool messages, right, if this is not empty, then what we're gonna do is we're gonna extend the messages array, not append, but extend, right? So we're gonna add more attributes to your messages object that was already there, right? So if you see the messages object, that is why I was saying that it is good that we are constructing it outside. So messages object was already an array, and you are extending it. By extending it, what it means is it's gonna put a comma over here and add the next element right here. So role tool, ID whatever, and content whatever inside an array, it is gonna add over here, right? So we are gonna extend that, and those multiple tools are going to be added in this particular messages object over here now. And then the final request to be made to the large language model, right? So now what we are going to do is, now there will be a final request that will be made, and the assistant will reply back over here. So this will be the final assistant response back over here in the messages object. So let's see what the final response will be. So let me do a clear. Let me run this Python, and this is 02, and let's hit enter. So again, there will be some delay because the LLM will need to be loaded over here in the VRAM. So let's wait for that. But now once the tool, so we are waiting for this right now, right? So we have constructed the messages like this, and this is the final assistant response that we are waiting for. So let's see that once we populate our messages with the tools object, how does the assistant response looks like? So we are waiting for this green, and we are gonna take a look over here how that looks like. So right now the model is being loaded into the VRAM, and now it is processing. You can see all four are showing the numbers, and there you go. It ran the tool. It is going back to the large language model in the second iteration and got the response back. Perfect. So let me show you what happened over here. So in this, we first sent the request, we got the tool response back over here, and then once we got the tool response back, we put it together and we sent it back to the large language model, and this is the final response that we got from the large language model. So the final response was that instead of just showing us this data from the tool, large language model actually tried to understand that what's going on, right? So if you see, the question that we had asked over here is it hotter in New Delhi or in Minneapolis, right? So it generated two different tool requests. It generated one tool request for New Delhi and another tool request for Minneapolis, right? And both these tool requests were sent to the large language model back. Like, hey, this is the tool request for this tool ID. This is the tool request for this tool ID. And now you go back and analyze and tell me which is hotter. And then it went back and it said that, hey, it is hotter in New Delhi with the temperature of this compared to Minnesota at this. And also it did some more analysis based on the data that it got. And this is pretty awesome, right? So now the final assistant response was not just the simple tool responses that we were spitting out of our Python code. No, we actually took those individual Python code examples, sent it back to the large language model, and large language model did some analysis on it, and then it sent us back the response. And this is huge because now we are getting an actual response back from the large language model, right? So we have everything in the flow. We had initial system message, we have user message, we have the intermediate assistant message that said that, hey, you gotta run this tool. You ran the tool, you created a tool response, you inserted the tool response in the messages, you sent it back to large language model, and large language model then finally sent you the response back. So in this interaction, anytime when there is a tool call, there will always be two AI responses back. The first AI response would be suggesting you to run a tool. And once you run that tool, you attach that tool to the messages, and then you send it back to AI, and your large language model will then respond back. And now that we understand this whole flow, now is the time to see our final example, a full-fledged example, right? Which is, it is an example that is just a refined version of everything else that we've seen. It uses term color over here to make the inputs and outputs very pretty. And you will see that every particular input or the request that is going to the large language model will be very clearly depicted and displayed, right? So in order for us to do that, let me utilize this terminal because it is a nice big terminal over here. It will be easier to visualize this too. So let me run this code over here, Python 03, and then I will walk over making a correlation with the code. So I'm going to run this. So as soon as I run it, this is what the initial request payload is, right? So what is that initial request payload? So the initial request payload is our payload that has model, messages, tools, and this keep alive attribute, right? So these four attributes are in there, but let's take a look how it looks like. So it looks like this. Model is this, messages, role is system, content is you are a smart AI assistant and you have access to tools and whatnot and everything else, right? This is the system context. And then there's a role user, and then it says that user is trying to know, is it hotter in New Delhi or in Minneapolis? And how hot is it? I want to plan a visit to a cooler place, right? And we are also passing the tool definition over here that, hey, you do have access to a tool, right? The tool that you have access to is called get weather. It doesn't know anything else. That's all that the large language model would know, that there is a tool called getWeather that exists somewhere in the Python code, and it does this, right? Whatever this is, it is what the getWeather function does. And it will see that, hey, if the user is asking a question that I cannot answer, it will look into the list of tools and it will see, oh, there is a getWeather function that does all this. So why not I ask the user to run this particular function and get me the response back, which is what it will attempt to do. So I have paused the program over here. I'll hit enter. And as soon as I hit enter, this request will go to the large language model, right? So it is gonna load. So up until now, the request was just staying on here. It didn't go. It is now being sent to the large language model, and the large language model will now, your LLM will now utilize this particular input format, right? So it will say that, hey, this is the request. These are the tools available, and you can have multiple tools. You do not need to have just one tool. You can have multiple tools available over here for the large language model, right? So there is an array. This is an array of different tools, and you can pass in multiple tools, and then the LLM can make a determination. Okay, so now this is the response back, you see? So when we sent this particular request to LLM, it sent us this response back. And what is this response? You see, the role assistant has content of none. It said, nope, I cannot answer this question. It's beyond my capacity to answer which is hotter between New Delhi and Minneapolis right now, right? And how hot is it and all that, right? I cannot answer this. So it just came back as no response. However, it told us that, hey, you need to run tool calls. So now it gave us one tool call. You see, this is an array again, right? So this is an array, and there are two tool calls in here, one tool call and second tool call. So the first tool call says that this is the tool call ID, and you need to run the get weather function, and the arguments of that is New Delhi, India. The second tool call ID is this. You need to run get weather function, and the argument to that is Minneapolis, right? And this is it. So it gave that response back to our Python program. And now it is our Python program's responsibility. So let's see where in the code we are at. So the initial request that we sent was over here, right? And once we sent that initial request, we got the response back, and this is where we are at. We got the response back and we have paused, right? So it says press enter to proceed with tool calls, right? So if you see, press enter to proceed with tool calls. So we have received the first response back from the large language model, and we are just waiting to run the weather API tool calls. And how do we run those weather API tool calls, right? So we are dynamically, so in this case, if you see, we are dynamically extracting the function name. It does not say when we are running the function, it does not say that we are running the get weather function, right? It is dynamically extracting the function name from the call, and it is dynamically extracting the arguments from the call too, right? So it is loading the arguments and it is loading the function name. And once it is getting the function name and the arguments, it is running that particular function. And it is then printing the result of the tool call, right? So let's hit enter over here and let's proceed with the get weather API call. And this is what happened, right? So you got the response back for New Delhi and you got the response back for Minneapolis, right? So you got these two responses back. And now it is saying that, hey, the tool call is finished, right? So your Python code is done running the tools that were suggested by the large language model. You're done processing them. Now go ahead and send this result back to large language model, right? So where we are at. So in the code, we are at a point where we have executed the tools, right? We have executed them and we have appended the tool messages into this tool messages array. So we have created a tool messages array. We have appended those two tool messages over here in this array. And now we'll be associating this tool messages array to our main messages object, right? So let's see. So from here, it is saying that press enter to generate the final request payload. Let's take a look at that. So in the final request payload, what we are saying is that, hey, this was the initial request and all that. We ran the tool. And once we ran the tool, these are the two role tool, right? So role is tool and role is tool. These are the two tool calls. And these are the results, contents of those tool calls. And these are tool call IDs that you asked me to run. Right? So now we have generated everything. We have system, user, assistant, and tool in the messages. And now we are going to send this whole structure back to the large language model and hoping to get this answer back, right? So the user message was not just a simple what is the weather in this case. The user message was actually bigger than that. User message was, hey, between these two, which is hotter and how hot is it? And I want to plan to visit the cooler place, right? So now the large language model, based on the information it has from those two tool runs, it is going to generate this exact answer, right? So let's see. So now it is processing it, and this is going to generate the answer, which is based on the current temperature. It is hotter in New Delhi with a feels like temperature of 95 compared to Minneapolis with a feels like temperature of 62. Therefore, considering your preference for a cooler place, I would recommend planning a visit to Minneapolis over New Delhi. And it also says that the tool call response was used and the weather APIs were used over here. And why did it say that? So if you go back in the system message, what I've also specified is that if you utilize a tool call, right, to get the final response, you need to let the user know that you have used a tool call. If you use some kind of tool, then just highlight it to the user that you have used a tool in your response, and which is why the system message is important over here. So system message did two things. It made the large language model aware that you have access to some tools, so go ahead and use those tools. And also it said that it used a tool call to get the final response, right? And this builds our trust in this response too. Because if, let's say, this was a production application which did not have all these debug messages in nice pretty colors over here, then you would send a request and you will just get this green response back. So if in the response you get some kind of confirmation that a tool call was used, then you will feel confident that the answer is accurate too. All right, so this is all that I wanted to show, because the intricacies of function calling and tool calling, they come up a lot of time in different scenarios, and understanding how exactly tool call works and how you have to construct your messages from top to bottom, right, is very important. And having this tool call sent back to the system and then getting a response back from the assistant is very important, right? So putting all these pieces together is important for us. I've created a GitHub repo and all the code is out there. So if you go to github.com teachings, over here there is an Ollama native tool calling. I believe this is where all the code is. Yep, this is exactly where it is. And I've uploaded the code over here. You can go ahead, take a look, play around with it. The only thing I think that you'll have to do, so in the requirements.txt, you have these two dependencies that you can download by running the pip install command, and then you will be good to go. Also, in case you have any questions or comments on this video, please let me know. I'll be extending this particular feature, the tool decorator feature that we have over here, for my mgraph. So I'm also building a framework, or I call it LangGraph like framework, but I'm trying to build a very lightweight framework called mgraph. And I'm going to be adding this particular feature of utilizing your tool descriptor dynamic definition functionality into the mgraph. So if you haven't watched that video, please check out that video too. And I will add a link to that video in the description over here too. Anyway, thank you guys for watching this video, and I will see you guys in the next one.